functions. So we can combine functions if we have two functions, f of x and g of x, and we want the combination function f plus g of x. All we have to do is add f of x and g of x. And it works for subtraction and multiplication and division. So f minus g of x is f of x minus g of x. F times g of x is f of x times g of x. And f divided by g of x is f of x divided by g of x, where g of x does not equal 0, because we can't ever divide by 0. So, for example, if f of x is 3x squared minus 4, and g of x is 4x plus 5, f plus g of x is going to be f of x plus g of x, which is going to be 3x squared minus 4, because that's f of x, plus 4x plus 5, because that's g of x. And we combine our like terms. That's 3x squared plus 4x plus 1. Plus 5 minus 4 is plus 1. Similarly, f minus g of x is going to be f of x minus g of x, which is going to be 3x squared minus 4 minus 4x plus 5. When you do this, make sure that you put g of x in parentheses because the minus needs to apply to all of g of x. You need to distribute this negative. So this is 3x squared minus 4 minus 4x minus 5. Distribute your negative. And then we combine our like terms again, and this is 3x squared minus 4x minus 9. To multiply these functions, we're going to multiply f of x times g of x. So 3x squared minus 4 times 4x plus 5. To multiply these, we need to FOIL. So we're going to multiply the first terms. That's going to be 12x cubed. We're going to multiply the outer terms. That's 15x squared. Inner terms is minus 16x. And the last terms is minus 20. And here we don't have any like terms, so there's nothing to combine. This is our final answer. And then f over g of x is f of x over g of x, which is 3x squared minus 4 over 4x plus 5. If there was anything to cancel out, we would cancel out like terms, but there's nothing to cancel, so this is just it. Each year, thousands of people visit Yellowstone National Park in Wyoming. Audio tapes from visitors include interviews with early settlers and information about the geology, wildlife, and activities of the park. The revenue R of x from the sale of x tapes is R of x equals 9.5x. Suppose the function of the cost of manufacturing x tapes is C of x equals 0.8x plus 1940. What does the 9.5 stand for in the revenue function? Right? So x is the number of tapes, and R of x is the revenue. That's how much money you make from selling x tapes. 9.5 is the let's say price per tape. All right. Similarly, in the cost function, the 0.8 is the cost per tape to produce them. And the 1940 is what's called a fixed cost. You have to pay that $19.40 even if you don't produce any tapes. So even if you produce 0 tape, you're going to have to pay tapes. You have to pay that fixed cost. The profit function is equal to the revenue minus the cost. Profit is what you have left over after you pay all of your costs. So this is the amount of money you make. And this is your cost. And your profit is money left over. So our revenue function is 9.5x, and our cost function is 0.8x plus 1940. Distribute the negative and combine our like terms. 9.5x minus 0.8x is 8.7x minus 1940. So what is the profit on 500 tapes? Remember, what we just found is our profit function. So we can plug the number of tapes into the profit function to get the profit for that many tapes. So P of 500 is 8.7 times 500 minus 1940. Which is $2,410. For 1,000 tapes, P of 1,000 is going to be 8.7 times 1,000 minus 1940, which is $6,760. And for 5,000 tapes, P of 5,000 equals 8.7 times 5,000 minus 1940, which ends up being a lot. $41,560. Composite functions are when we plug one function into another function. So composite functions take the range of one function, right? Remember, the range is the output of one function, and use it as the domain or the input of another function. So we have some function f of x, and we plug the numbers, the input, the domain of f of x into f of x, and that gives us some output that is the range of f of x. We take that output and use that as the input for g of x, and then we get a range for g of x. That is the output. So if, for example, f of x equals x plus 1 and g of x equals x squared, we have f of g of x. That's what this is. This is f of g of x. And so we work from the inside out. What it's telling us is to take g of x and plug that into f of x. So that the range, right, so x here is the domain, x squared is the range for all values in the domain. So we take that range of g of x and we make it the domain, which is the x of f of x. So this is f of x squared, which would be x squared plus 1. The x turns into an x squared. G of f of x just means doing it the other way around. We're going to take f of x equal to x plus 1, so this is the domain, and this is the range. And we're going to take that range and plug it in to g of x. So g of x plus 1 would be x plus 1 squared. So the x turns into an x plus 1, and then we square it. And in order to square that, we need to FOIL it, and that's going to be x squared plus 2x plus 1. Note here that f of g of x is not the same thing as g of f of x. All right, here we got x squared plus 1, here we got x squared plus 2x plus 1. So the order matters. All right, do it again. F of x is 2x squared minus 3x plus 8. G of x is 5x minus 6. F of g of x means that we take g of x and plug it into f of x. So this is f of 5x minus 6, which means that all of the x's in the f of x function become 5x minus 6. And then to simplify this, we need to FOIL 5x minus 6 times 5x minus 6, and that is 25x squared minus 60x plus 36. Distribute the negative 3, minus 15x plus 18 plus 8. And combine our like terms. This is 50x squared. We're distributing the 2. Minus 120x minus 15x is minus 135x. Plus 72 plus 18 would be 90 plus 8 plus 98. G of x, 5x minus 6. So we're g of f of x, we're going to take f of x and plug it in for x. So this is g of 2x squared minus 3x plus 8, which means that the x in 5x minus 6 becomes a 2x squared minus 3x plus 8. Distribute the 5. 10x squared minus 15x plus 40 minus 6, which is 10x squared minus 15x plus 34. So what are the domains of these two functions? The domain of g of x is all real numbers, right, from negative infinity to infinity. G of x, if we graph it, is a line that goes from negative infinity to infinity. We can plug any possible value of x in there. F of x is a parabola, and I don't know exactly what it looks like, but it opens up, so it looks something like this, right? And so we can plug any possible value of x into this as well. So the domain for this is also going to be all real numbers or negative infinity to infinity. So because we can plug all real numbers into g of x, and then we can plug all real numbers into f of x, so anything that we get from g, we can then plug into x, the domain for f of g of x is also all real numbers. And because the domain for g of x is all real numbers, so anything we get from f, we can plug into g, the domain for this is also all real numbers. One more time, once more with feeling. F of x equals the square root of x minus 4, and g of x equals 1 over x squared. So f of g of x is f of 1 over x squared, which means that this is 1 over x squared minus 4. And that doesn't simplify. And then g of f of x is going to be g of the square root of x minus 4, which is 1 over the square root of x minus 4 squared, which is 1 over x minus 4. Domain of f of x, right? We can't take the square root of a negative. So this domain is only where x minus 4 is not negative, which means where x is greater than or equal to 4. And this is going to end up, if we write this in interval notation, this is from 4 to infinity. The domain of g of x, right? We have a fraction with a denominator. The denominator cannot be 0, so x cannot be 0, or from negative infinity to 0 and from 0 to infinity. Now, remember, we talked about in class, the domain of composite functions can be more restricted than the domains of the individual functions. So on the previous slide, the domains of both functions was all real numbers, so the domains of the composite functions were all real numbers. Here, though, that is not the case, right? So when we take g of x, we can't, when we put this into f of x, we can't, if we get a g of x, any g of x that is less than 4 will not go into f of x. So the domain here is only if g of x is greater than or equal to 4. Only if it fits in the domain of f of x. So 1 over x squared has to be greater than or equal to 4. If you solve this inequality, that's going to give you 4x squared is less than or equal to 1, which means that x squared less than or equal to 1/4, which means that either x is less than or equal to 1/2, x is greater than or equal to negative 1/2. Okay? So the domain of this function is only from negative 1/2 to positive 1/2. But also, we know that x can't be 0 because 0 doesn't go into g. So our domain becomes negative 1/2 to 0 and 0 to 1/2. anything bigger than 1/2, if you put it in for x, is going to give you a square root of a negative, right? Try it. Try x equals 1. 1 over 1 squared minus 4 is -3, and you can't take the square root of a negative. So this is the domain you get. Anything that is greater than 1/2 or less than -1/2 is going to be a problem, because then when you put it into x, you get the square root of a negative. And 0 is a problem because we can't put that into g. For g of f of x, right, we got this function here that 1 over x minus 4, but we still have to take into account the domain of f of x. So we still can't have anything less than 4 to start with, because then it doesn't fit into f of x. Now, in g of x, we can't have anything that divide by 0. So the square root of x minus 4 can't be 0, which means that x minus 4 can't be 0, which means that x can't equal 4. So x can't be less than 4 because that doesn't fit into f of x, and x can't equal 4 because if we plug 4 into f of x, we get 0, and if we plug 0 into g of x, we get undefined. So the domain here is not a square bracket, right? It's from 0, where's my brain? From 4 to infinity. With parentheses, because we can't include 4. So again, the domain of the composite functions is more restricted than the domains of the original functions.